Today is all about the easy button, or the easy way to store and access and retrieve your data. And we're going to show you how to do that with Fauna. I want to point out my emails on this slide. My Twitter handle is on every slide. If you have questions, feedback, of course, we all live on that stuff. We want to make this better every time that we give it. So I would welcome that feedback. DMs are open, or just ping me directly. Okay. So today I have 3 goals that I want to cover that we talked about in the abstract for the session, right? One, you should really walk away with an understanding of how to store and retrieve your data easily. You should have an idea about all of the things that you don't have to do. 2, I want to talk a little bit, not too much, about the algorithms behind this, because we promised that the simplicity and the speed comes out of new development. So we will get a little bit into the tech here. That's going to be at the end of this. But in the middle, I really just want to show you. So I'm really going to put myself out there today. We're going to go from signing up for a new account through deploying 3 global databases, all within this talk, different ways. One from the console, one from GraphQL, and one from the serverless framework. So whether you're a front-end developer looking to access data in your app via GraphQL, or a back-end developer looking to back your API with something that you don't have to worry about, I'm hoping that you learned something today to take away. I'm not sure if Brian mentioned it, but please, questions as we go. I'm happy to stop what I'm doing and address your questions. This is your session. This time is for you. I want to make sure you get those answered and you get the maximum benefit out of it. And please bear with me. I am sick, and so I will be drinking throughout this whole thing. So please bear with my pauses here. So first, what is Fauna? Fauna is the data API for modern applications, and there's a lot tied up in that definition, right? So we're talking all about data, we're talking about an API, and we're talking about modern applications like single-page apps, like serverless applications, containerized applications, even microservices. But really, any application that you're building for today and tomorrow can benefit from Fauna. You can add that migration functionality into legacy applications to get you into an up-to-date stack. But we break this down in a few ways. Because it is not a purpose-specific database like you might think of, it supports different models of accessing your data. Fauna is an operational database, not an analytics database. It can store your data with relationships like you're used to thinking about in an RDBMS. It can store your data as documents like you'd be accustomed to with a legacy NoSQL database. And it can store information about graphs or the relations between the bits of data in a graph format and retrieve them that way, because it has a powerful query language. We're not going to go so deep because the purpose of this topic is simplicity and ease. But it's important to know that underneath all of this is a full query language that gives you all of the power to access all of these models when you're ready for that power and complexity. Fauna is a multi-region data store, and this is a critical component of Fauna. Fauna stores your data in multiple regions depending on what you select. We announced a feature yesterday called region groups that I'm going to talk about a little bit later. But basically, you'll either store your data around the world, or in the US, or in the EU if you have GDPR requirements. You don't need to manage those clusters or synchronize those clusters or worry about, CRDTs and active-active failover. All of this stuff is transparent to you. You send your data to an API, and it's stored in all of those locations. You read your data from the API, it retrieves it from the closest location, which impacts speed that we'll get into a little later. Fauna is transactional, and this is another unique point for Fauna. You get the strength of ACID transactions, and I mean full ACID transactions here, we'll get into later, along with the ability to structure your data as documents and have those ACID transactions in multiple locations at the same time. And this is a lot faster than legacy systems because of some of these new algorithms that we talk about later in this talk that we'll get into. But it's important to know every read you make from Fauna is a strongly consistent read. So when you write data to Fauna, the next time you read, you're getting that data out, regardless of where you wrote from or regardless of where you're reading from, even in different regions for your cluster. And finally, Fauna's serverless. So that means there's no infrastructure for you to manage. You don't specify sizes for your database. It scales automatically and transparently for you. It's secure by design. And it, what's the last point? You pay only for the value that you use. So you'll see today we sign up for a free tier with no credit card. There's a lifetime free tier that you can use. And then when you go beyond that, you're charged based on your number of reads, writes, compute operations, put a pin in that, and the amount of data that you store. Now those compute operations are actually happening on your data. So this is that Fauna query language that I alluded to earlier. We'll talk a little bit more about that later and the power that it gives you. So a major value proposition of Fauna is all the stuff that you don't have to think about. Again, we said this is databases the easy way. Traditionally, you would do this that you see on the screen. You would either provision a virtual instance in a cloud provider or buy bare metal, put it in a rack somewhere, get some space for a data center, provision network connectivity, secure it, firewalls, NACLs, security groups, install an OS on it, lock that down, maintain patches over time, install your database, tune all your various configuration options, patch that over time. Now you've got clustering at the operating system level, clustering at the database level. That's for a traditional RDBMS. That's all work that you no longer do, right? This is all there. This is all done. But again, none of that work adds value for your customers. So you shouldn't concern yourself with any of that work. All you do is write your data, read your data, we take care of the rest of it. And the other aspect here at the bottom, if you're used to legacy NoSQL databases, most of them force you into single table design at a certain point to maintain their performance. Single table design is a solved problem at this point, but it's a very complicated problem that, again, doesn't add value for your customers. You can go through a 20-step process of remodeling your relational data to figure out how to smush, that's a technical term, smush it into a single table, or you can just write and read your data the way that you're already thinking about it with relationships and with the same performance. I know which one I'd pick, right? And performance is important. We're still talking single millisecond reads. And again, we'll get into that later. So you could set aside all of these complications that aren't adding value to your business or adding value for your customers when you build with Fauna. Lest you think I'm exaggerating, this is an official diagram for configuring cross VPC connectivity and failover with RDS. And if you dig into this diagram, all of these things are important. You have separate VPCs, you have firewall rules, you have routing between them, you have both NAT gateways and internet gateways, private public subnets, bastion hosts, primary replicas, secondary replicas, notification topics. All of this stuff is operations. At the end of all of this, you can write and read data from a database. This diagram, as complicated as it is, doesn't consider multi-region. Multi-region is another level beyond this. This is inside one region. Now you have to connect the private VPCs over VPN connections, ensure that those are up, pay for that traffic, etc., etc. Important note, Fauna is handling your traffic. Once you get it into Fauna, we're handling the traffic for the transaction replication, the cost there. You'll notice the pricing dimensions I talked about didn't include network. It included read, write, compute, and storage. So those are the things that you can easily plan for, and those are the things that pricing is based on as you consume them. So that's the RDBMS stuff that you can set aside. This is the single table design stuff that you can set aside. Let me try something I've never done. Let me try to zoom in on this slide on stream. Let's see if this backfires or not. No, it doesn't like that. It's a little bit hard to see on this slide, but each row, if you will, each item has different fields, different column names. So if you're not familiar with single table design, this might be breaking your brain right now. And again, the whole point of this is to get to a point where you can effectively write and read your data to and from your data store. So you no longer have to do this with Fauna. Again, just take a record, write a record, take a document, write a document, read a graph, establish a relationship, pull it out. We're going to go into the demo, but this is what you do to get yourself a globally replicated database in Fauna. You go to create database, you create an API key for it, you put that key into your application and begin accessing your data. And that's it. That's everything that we just showed you on those 2 slides is replaced by this. So that's why we call it the easy way. If this sounds familiar, it's because you're probably already doing this in your apps. If you use a managed service like Stripe or Twilio, Algolia for search, it's the same principle. You define what you need from that service. You get an access key that's either permanent or is based on credentials and an authentication flow. And then you use that service. You send data to and receive data from that service based on the needs of your application. Exact same thing here. So I haven't seen any questions come in yet. I'm going to jump into a demo, and I'm going to spend quite a bit of time in this demo showing you the 3 easy ways to get started with Fauna. So let's do this. I'll give you all these links at the end. If you go to fauna.link/signup, it'll take you here. Again, I'm taking the easy way challenge here. We're going to create a new account, brand new database. Let's go. I don't actually want to be in the Slack for this because I'm already in the Slack. You can leave that. Come join us in the Slack. We'd love to hear from you. So you can sign up with GitHub or with Netlify and use SSO and you're in even more quickly. I've already done that. So, also shout out to Netlify for sponsoring Brian's meetups. Netlify, it's like the Fauna for compute. They're not going to like that. But we love Netlify at Fauna, and that's why we integrated with them. I'll give you another link for Netlify later in this event. Provide a username, provide a password, sign up with our email. Let's see how the demo feels like treating me today. Don't worry, y'all. I have like 18 accounts, so if this doesn't work, then... oh, look, here we are. No, let's not save this right now. So you see, at this point, this is a brand new account. I haven't put any credit card information in. We're on the free plan, right? If you want more information about that, you've got your upgrade button over here, and you can look at plans, billing, pricing. Not the purpose of this demo. We hope you'll upgrade once you see how incredibly easy it is to build with Fauna. Create a database, and here's that lovely little screen that I showed you on the last slide. So we're just going to call it CFE. Again, we'll go back and talk about region groups later, but I'm going to select Classic. And what this means is my data is replicated worldwide when I write to it, and then available at local points for me to read from. We're going to create it, and it's here. Like that's it. Now we have all of that work from the RDBMS slide is completed, right? We have a secure data store, global replication, where we can create and retrieve data. So I want to demonstrate an important feature of this. Let's call this events. You can keep history of a document. Temporality is an advanced feature. That's for another day. You can keep time to live. If you have data that expires and you want to remove it out, set this. That's an advanced feature. That's for another day. All you have to do now is give your collection a name. And collections are collections of documents. So they're like tables, right? Oh, yeah, I can't use events. That's silly of me. CFE events. And we have this collection. Now, you're not going to put data into your database in the console here, but I want to just demonstrate a point. We can create one document with this format. Since it's a CFE event, this is today's talk, right? Database is made easy. On today, the presenter's me. Notice all of these are strings, right? So we save this document, and that's great. That's fantastic. Got a little bit of information about its reference, the timestamp for when it was created, and our document, just like we expect. We can also create another document, and Brian talked about more serverless coming up, so let's use that as an example. More serverless is coming up on August 12th. And unlike this talk, there are a number of quality speakers that you won't want to miss, and also me. So in this case, we see that presenter, same key, is an array of strings. We can save that. Fauna doesn't complain about that because it's allowing you to treat your data like a document. You could also not specify the presenter field. So you aren't limited to the modeling of relational databases if you don't want to be. You can treat it as a document data store. Now, there are other ways to ensure that that modeling is done, and one of the best and most common is GraphQL. So let's go back and look at another feature of our database. We can create a child database here called GraphQL. This is a common scenario for, and it's done. See, it's done. New database. This is a common scenario for multi-tenant applications like SaaS apps. You can create a separate database for every customer that you have with separate keys, separate authentication, etc. And there's strong isolation between every database, including between parent and child databases in Fauna. Now, if you're going to do this, you'll want to take advantage of some advanced features. Again, this isn't an advanced talk, but we want you to know that it's there and it's available. So to get started with GraphQL, we just import our schema. Let me jump to VS Code real quick and show you what this schema looks like. I'm gonna make this a little bigger for y'all. Sorry, I'm originally Southern, so you'll have to put up with my y'alls and whatnots. All right, so we have a couple types here. We have a type user, a type address with an embedded decoration. And we see that address is referenced here in user. We have a type session, right, with some information about the session. And we have a type reservation, which consists of one user attending one session, right? Whoops, unless I delete it. So we have 4 types here, but because one of them is embedded, we don't expect to see that created in Fauna. This is our file schema.graphql. Let's go back and import that. We import this, and that's about 3 seconds there. And we see that Fauna has given us a schema that's much more robust. Oops. Sorry, y'all, mousing is hard. You see that it's taken our definition and it's given us an address. And this is an embedded type. It's given us an address input, which is a generated input for mutations. It's created a list of mutations for us, and all of these are defined automatically for us. So we can, and in fact will here in a second, call these mutations against our database just by uploading the schema. It's also created the relationships, some queries for our access patterns, and these relations between the many-to-many, or the, I forget what you call it now. It's hazard of cold medicine. Associative entity, there it is, for reservations for one user attending one session. And so all of this is created for us. We can download this and use it in our app. There's a lot of advanced functionality that we won't get into today because we're talking about the easy way and how to get started. But again, you want to know it's there. So we go back to VS Code. Let's drop a little bit of sample data in here. Let's give ourselves some sessions and some users. Before we do that, let's go look at what was created, right? All 3 of these collections are empty, and you notice there's no address collection. That's because address was an embedded entity. And that means that Fauna is going to treat that more like a document and write it as a nested entity inside user. It also means you can refer to it separately and update it separately with GraphQL. So there's some advantages to that. But it will live underneath user. And right now, all of these are empty, which is what we'd expect. You notice you have your GraphQL endpoint here that you can consume in your client application or your website. We're just going to paste that mutation. We run it. And, as promised, all of these entities have been created and have been given IDs. And the magic in this is that we haven't done anything other than define some data types and upload a schema. But yet we already have these mutations available to us. And now if we go back and look in the collections, we see that we have these 3 sessions that we defined and these 3 users who we've defined. We don't have any reservations yet. The reason we don't have any reservations is because I don't know how to GraphQL good enough to get all of that in one mutation. So we're about to put them in there in a second mutation that shows you how to connect existing entities in an associative entity like that. So this is we're going to create 3 reservations, one for Alice in the beginner course, one for Bob in the intermediate course, one for Carol in the advanced course. And we're just going to replace these with the identities that we got from our previous query. This is how you do that with Fauna, is with that connect statement. Again, we're out beyond the limits of my GraphQL knowledge. Maybe there's a more elegant way to do this in one mutation. I would love to see it. Share that with me if you're seeing this in the future on Twitter. Share that with me on Twitter if you are seeing this in the future. Would have been a better way to word that. All right. Now I need to go back here. We'll give ourselves a new tab. This is that new mutation to populate our sample reservations. We'll need to copy and paste some data out of here. I'll do this as quickly as possible. Maybe I'll only do this for one because the point remains the same, right? The point is just to show you that we can create and connect these reservations for all of our users. And then we'll just create this one reservation right now so that we don't have to copy and paste a bunch of information over. Ta-da! And so now we see that we have this reservation for Alice to intro to Fauna. And again, we return to our collections. And now we have one document, which is just, if you want to think about this like a relational database, a foreign key or a reference to the user, which is Alice, and a reference to the session, which is intro to Fauna. So there you have it. Oh, one more thing. Those queries were created as well. I do want to jump back over and give you a quick look just to see that these were created. We go in here, we have find session by ID, for example, and we want to look for the 211 session, and we expect to see the information about that. So again, it's just the opposite of a mutation. We have this query, and we get all the data. And remember, we haven't written any code at this point to do this. Fauna has generated the business logic and the data access rules for those data access patterns for us, just by virtue of us having uploaded that schema to GraphQL. So easy way, right? So far, live demo, brand new account. Got 2 ways to access data. I'd say this is going pretty well. Let's see what happens next, shall we? I do want to point out we're in this database, GraphQL, and we have these collections. Again, those collections aren't visible from our parent database and the other way around. The parent database collections aren't visible from GraphQL. So again, that strong isolation is right there for you. Let's create another database. Let's call this one serverless. Again, boom, separate database. Let's give ourselves a key. Please don't go in here. Let me take this. Let me do this the right way. Let me take this off screen if I can. Create a little key up here. Copy that key out. Copy. I did it anyway. Y'all, it's the worst. It's the worst. Every single time I stream, I dox myself like that. Well, what are you gonna do? What are you gonna do? Let's save that key. Let's do echo fauna secret equals and send that to env file, and then let's pb paste. Let's see if we did this right, if I can avoid doxing myself again. And now we're going to clone this repo that we have on Fauna Labs, a collection of helpful utilities, examples, and tools to help you build with Fauna as you move from easy to intermediate and beyond. We have a serverless Fauna example. So let's clone that. Let's move our .env file there and get out of here for a while. Now we're on to our third way, and this is building a backend. So what we have here is an API using the serverless framework. And there's a Fauna plugin for the serverless framework. And you can see you can set these values. We've set them to come in from the environment. But basically, this is all of the stuff that you will get if you select populate sample data in the dashboard. So this shows you how to build out your database as infrastructure as code. So we're going to deploy this, and in less than a minute, we're going to have a full API with HTTPS, multiple endpoints, collection that's populated, everything we need, right? So first things first, we need to install. First things first, we need to change to our directory and install npm. This will install our plugin and our driver. And that's really all we need here. Nice, live. So far, so good. Now that that's installed, we can do serverless fauna deploy. This is not going to deploy the entire application. It's only going to deploy our data aspects. Where did I create this? I did not. Hold on, y'all. This is a key thing because I ran into this during rehearsal as well. Hey, you've already seen my key. Let's see what's in there. Oh, that's why. Okay. See? It's why you always rehearse. It's why you rehearse. You know you're going to run into it. And so now this is going out and creating collections, indexes, functions, and roles in our application. So we can go back here. And you see we didn't have any collections before. And now it's provisioned all 4 of these collections in here that are defined in our database. So we already have the structure of our data populated. If we want to populate some data, we can do serverless invoke function seed. I don't know if this will work when I haven't deployed the entire app. Let's see how it goes. No. So we'll need to deploy the entire app. There won't be any Fauna changes to deploy. This is going to put some Lambda functions in our AWS account that we have over here. Currently, no functions. In a minute, we're going to have some functions. But for right now, we don't. So this takes a little bit. It's a little bit less than a minute. But again, what we're talking about is our third globally replicated database. And when this minute is up, that's fronted with an API with SSL or TLS certificates, fully connected. And so immediately you can start adding in your business rules and other logic for your application. I'm going to take advantage. Oh, look at that. I'm going to take advantage of this time to hydrate a little. We're almost there, y'all. We're almost there. And then once this is done, we'll be able to seed that data, call our endpoint, and we'll have created 3 databases during this talk. So I tell you what, let's let this finish. Let's go back to the slides in the interest of respecting everybody's time. We'll come back and check on that in a minute. A little bit of tech. I promised you some information about the algorithms behind all this. Transactions in Fauna are ACID transactions. Atomicity. Atomicity? Either everything happens or nothing happens. This is the classic, again, Fauna transactions are real transactions. If you want to understand more, I'd refer you to the Jepsen study, the Jepsen evaluation. But atomicity, it all happens or nothing happens. Consistency, which means that the data in the database is correct. This is sometimes also called correctness. Isolation, in that one transaction cannot affect the outcome of another transaction. And this becomes important in a couple slides. And durability, meaning they're persisted to disk. So if a component fails, the data is still there once the transaction is completed. Fauna gives you ACID transactions and is globally distributed, which is a big deal. Fauna does not do two-phase commits. This is the classical way of replication amongst databases. And if you look at this sequence diagram, you see that there's a hierarchy here. There's a primary and a secondary. They have to agree on what's about to be done. They do it and then notify and then do it and then notify, and then the entire transaction is committed. So you've got multiple round trips here. Your applications today are hitting speed of light limitations on this, right? So this is 2 round trips and a lot of potential for blocking, which is worse because you can't be doing anything else during those round trips. Plus, if your primary fails, you can get into a permanently locked state. Yes, there are algorithms that resolve this now and it's a little bit better, but ultimately a 2-phase commit doesn't work for a distributed database very well, especially globally, because of the speed of light limitations that you have. Instead, Fauna is informed by Calvin. Calvin's a paper out of Yale University, Dr. Abedi and others, 2012. Can you tell I've referred to this a couple times? And you can read the original paper at the link on the slide, which I apologize for not highlighting. That's fauna.link/Calvin. Fauna replicates the inputs to the transaction rather than the effects of the transaction. If this sounds a lot like event sourcing, it is. It means Fauna participants agree on what deterministic actions are going to be taken in a transaction in one round, and then they move on to the next round. They just apply them and move on. So there's one cycle of coordination. This still gives you strongly consistent reads because every participant in the cluster or the replication set has agreed to perform the same deterministic actions. And we hinted at this a little bit earlier in the talk. The determinism of these is what makes this work. And this applies to compute, it applies to read, it applies to writes. Everything that's done is done to sustain those ACID transactions in a deterministic manner so that only the one round trip is required. What this gives you is a lot of speed. That single phase commit on your writes means that you can have, depending on your region group, double-digit millisecond writes, and that's to every participant in the cluster, and gives you single-digit millisecond reads, which is competitive with other legacy NoSQL solutions that are out there. The one that we've shown you on this slide, of course, is the European Union region group because it's the smallest, has the least speed of light effects. The US region group is also under 100 milliseconds. The global region group is only slightly above 100 milliseconds, which is still pretty impressive when you consider how big the world is. You can see those numbers for yourself on status.fauna.com as you see on this slide. And again, region groups are a new feature that we just announced yesterday. If you have requirements for data residency, in particular around European Union requirements and GDPR, definitely check it out when you're creating your application. We created our example databases for this talk in the global region just to show you the worst case scenario where all of this stuff still happens instantly compared to all of the work that you would have needed to do with an RDBMS solution that's globally replicated. So let's go back and check on our stack. The point of all of this is that you can have it all. You can have the serverless data store, ACID transactions, global replication, ease of use, pay-as-you-go pricing. Can't think of any reason to store your data anywhere else, right? So let's get back to VS Code. Our schema is up to date in Fauna. We have these URLs. Right now, there's not going to be anything for us to retrieve because we haven't put any data in there. So it's going to be empty. Empty seems right to me. Let's invoke our seed function and put some data in there again. Success. And now, again, we get this list of products back that comes from our database in Fauna. So as promised, 3 databases, one created in the console, one created by uploading a GraphQL schema, and one created using infrastructure as code for 3 different types of applications for you to go out and build into your application. I want to jump back over to here. I want to take some time, take your questions if you have any. And again, as always, thank you for joining. Go out there and build. Again, you saw we created a brand new account in this demo. So you can go out there and build without putting in a credit card without exposing yourself to any financial charges. There's a free tier. When you hit the free tier limit, you'll just be capped. You won't be charged. So it's a very safe learning environment. Recommend you start with the 5-minute quick start. There's a Vercel integration that you can check out for integrating Fauna databases into your Vercel app if you have them. There's also a Netlify integration, fauna.link/Netlify. I apologize for omitting that here. And then the serverless framework plugin, if you're a backend builder, is also linked here on the slide, fauna.link/serverless. Thank you.
Thanks, Rob. That was awesome. I've actually had some experience using Fauna before. So I'll ask. I have a few questions of my own.
Yeah.
So you showed two different ways of building the application. One was, you were doing it manually via the admin UI, and then the other was to create it via GraphQL. Is there any difference between the databases that are created doing it either way? Are there any limitations or anything like that you would get doing it one way versus the other?
The limitation with GraphQL is less a limitation and more a helpful guardrail. GraphQL is a transport protocol essentially, right? The schema is your interface definition language. And so you cannot submit data or retrieve data that does not match your schema when you're using GraphQL. When you're doing it outside of GraphQL with just API calls, you can yeet as much data as you want into there in whatever shape you want. That is a strength and a consideration for putting guardrails around. Now, one of the, we're going to move into intermediate theory of Fauna here, but one of the guiding principles of building with Fauna is to always wrap everything in a user-defined function when you're calling it from your client. And that's one way you enforce those business rules. Is this data shaped correctly? Is it coming from an old client? I can mangle that data to the new format, store it, return the data in the old format that the old client expects, even though my database has moved on. So you can have multiple versions concurrently. All of that functionality is there. The outside of GraphQL operation is the freedom to do whatever you want and the corresponding consequences. The GraphQL schema is the restriction to match the data types and the corresponding benefits.
Okay, so I get it. So that's why, like in your first example, you were putting two different documents that had different. Obviously, you couldn't do that because that value for presenter or whatever you called it in your in the data you were putting would either have to be a string or an array in the GraphQL schema. It couldn't be either or, like the way you did it.
Correct. That's by the GraphQL spec, right?
Yeah.
Now, you can do migrations, and I'm doing a whole Twitch and blog series on this right now. So maybe you used to have presenter as a string and have a new business requirement to have presenter as an array of strings. You can perform that migration. Again, that's an intermediate to advanced topic. I'd refer you out to those. So it can change over time. But at any given point in time, you can only have one active GraphQL schema, and all operations must comply with that schema, or they're going to be rejected by the GraphQL layer, according to the GraphQL spec.
Okay, so if I create it via GraphQL, I have to query it via GraphQL, or is there REST endpoints for that as well?
If you create it via GraphQL, you can access it either way. If you create it outside of GraphQL, unless you specify it in your GraphQL schema, you cannot access it in GraphQL.
Okay.
If you create it outside of GraphQL and later want to access it, then you specify it with a collection decorator. So we showed you the embedded decorator on a type. You can also use the collection decorator that says, okay, for this GraphQL data type, I want you to use this collection that's defined in my Fauna database. And now they become associated.
Okay, that makes sense. And I know we didn't really get into it, but one of the things that was new to me when I started trying to use it was the whole FQL thing. So can you explain a little bit about what FQL is and what's the benefit of using it?
Yeah, there are a couple benefits, and let's again talk about it. Are you using GraphQL or not? If you are using GraphQL, you won't run into FQL until you want to modify what's provided for you by default. This can be you need an additional query that isn't provided, an additional data access pattern. And what you'll want to do there is write a user-defined function that you use as your resolver for your query or mutation. This is true of GraphQL wherever you deploy it, right? GraphQL is this transport layer. There's some business logic or data access layer behind GraphQL that performs business rule, logic, and validation before and after writing to and from the database. If you were backed by Express, then Express would be that layer writing in some other data store. In Fauna's case, it's FQL that is the language that you're directly manipulating the database. And FQL is it helps if you know functional programming. It's very similar to Lisp. It's a prefix language where you know and a comma b if you want to evaluate that both a and b are true. But it is learnable. It's specific to Fauna and extremely powerful. And we're working to properly order the easiest way to glide in from GraphQL to designing your own resolvers. Now, if you're working outside of GraphQL entirely, you're going to hit FQL immediately because, again, that's what you write these UDFs or user-defined functions in that manipulate the data that's in your database.
Right. Yeah, I know my one experience building something with it, I did end up using FQL quite a bit because I wasn't using GraphQL. So if I recall, the SDK, when you like the JavaScript SDK, kind of replicates the way of writing things in FQL when to write your queries within your front end. So yeah.
Yeah. And it's not a string-based language, which means it's secured against attacks like SQL injection, right?
Okay.
So it's an embedded DSL. You are consuming it from within the language that you're writing in, JavaScript, Python, C#, etc. You don't have to worry about that SQL injection, but you can write FQL queries. And I mentioned Fauna Labs earlier. We have a section of blueprints that are FQL queries that you can embed in your own application to help you get started quickly for common tasks, change a password, validate an email and password, authenticate refresh tokens, etc. Those common but not simple tasks are already there for you to learn from. That's Fauna Blueprints.
Cool. Awesome.
In Fauna Labs.
So yeah, I don't see any other questions from the audience. If anybody has any final questions, we've just got a few more minutes. So if you want to post them in there, I'll make sure Rob gets to it real quickly. So one last question, just to kind of give folks a few seconds here to respond, if anybody has any last minute questions. So you were talked about creating like a parent database and then child databases under that parent database, but that they were all kind of independent of each other. So what's the value of having them, or is it just an organization thing, or is there some way that they're interconnected?
It's an organization thing.
Okay.
Now, when you look at your billing and reporting, all of that rolls up. So you can see, for example, if you have a production application, a test application, a QA app or staging application, and then under production, you have all of your customer accounts, then they would roll up underneath production. So you could see it from, use compared to the others. But it's organization. I mean, everything is essentially a document, and Fauna, a database, is a document, and every document can have child documents. So it's documents all the way down.
Okay, makes sense. So is that kind of a common way of like having you'd have a child database that would be like staging and development? Is that, or do you do it a different way?
I would recommend a different database for every environment. There's a couple reasons for this. One, the region groups have different prices. Based on the actual price of the underlying compute. So you could do your test, QA, et cetera, in the cheapest region, and then run production where you need to run it. Or if you have, maybe you need the fastest region for production, but not for test, et cetera. So you can, now maybe you want them to match exactly. For me, I wouldn't say this is a best practice. I would say this is a Rob practice. I would separate the environments at the database level And then if I created child databases underneath, it would be for multi-tenancy.
Okay. Okay. And so like
But that's
if
a
I'm
pattern. That's not
yeah.
right or wrong. That's a pattern.
Okay. But if I were doing that, do I then can I easily like say replicate the data from production back down to staging, or if if I want to keep this, allow them sync them?
Yeah, not easily. It's something we're working on right now.
Okay.
Is both replication of environments, moving environments, exactly the use case you're talking about, populating pre-production environments with filtered data, etc. All of this is possible because of FQL and the power of having a functional language right there on your data. But it's a matter of getting the right bits for customers first, the small but most important functionality. We're working through that right now. At literally a meeting later today on that. So
Okay. Good.
we're
Well,
aware
I'll
and we're
look
working
forward
on
to
it.
it. Awesome.
But but there are ways to populate your data using a tool like the Fauna shell from the command line and running predefined queries to get data in there to have consistent test environments, etc.
Okay. Awesome.